Let's consider one more national income model. And this time, let's take a slightly more complicated national income model with taxes. Okay. Remember this model right here? Y equals C plus I plus G. C equals A plus B times Y minus T. Now, consumption is a linear function of disposable income, or Y minus T is disposable income after taxes. And then finally, let's assume taxes. Oh, let's make it the tax equation just a little bit simpler. Let's assume there's no intercept in the tax equation. So the tax equation is just capital T equals little t times y. Okay. Where little t in words is what? Little t is the tax rate. Okay. And the tax rate, you could just think as the marginal income tax rate, is some number between 0 and 1. As before, we will assume that the parameter A is positive and B, the marginal propensity to consume, is between 0 and 1. Okay. And again, if we want to know how Y star is going to be affected, or if we want to know how Y star is going to be affected by a change in one of the parameters or one of the exogenous variables, the first step is to solve for Y star. Okay? And how would we solve for Y star, the equilibrium value of national income? How would we go about solving for Y star? Yes, William. Okay, well, you want to substitute the t equation into here? Okay, and then do what? Right. Yes, okay. So let's do that. Actually, let me just do what you said in just a slightly different order. Let's first substitute C into this equation, and then we'll do what you said, William, substitute T in here. But it amounts to the same thing as what you said. If we substitute C into that top equation, we would get Y equals A plus B times Y minus T plus I plus G. And now let's do what William said. Let's substitute in for capital T in this expression right here. Okay. So then we get Y equals A plus B times Y minus TY, substituting for T, plus I plus G. Now, notice what we've accomplished. We now have only one endogenous variable in that equation. So now we can get all the y terms over to the left and solve for y. So doing so, we get y. Now we have a by here. We've got to move it over. Minus by. We're going to have a minus bty. Bring it over to the other side, it becomes a plus bty equals A plus I plus G. Okay. Now, what do we do next, William? Exactly. We factor out the y on the left-hand side. And then we can write this left-hand side as what, William? Exactly. Y times 1 minus B plus BT equals A plus I plus G. And then the last step, William, is to do what? Yeah, divide by that expression in parentheses, 1 minus B plus BT. So now we get our equilibrium value of Y as A plus I plus G over 1 minus B plus BT. Okay. So now the comparative static derivatives of interest are these. Let's do the parameters first. Partial Y star, partial A, partial Y star, partial B, and partial Y star, partial T, little t. Okay. And what is partial Y star, partial A? Hal, let's let somebody else. You've already answered this same question 3 times. So let's give somebody else a chance. Sean? That's it, exactly. The coefficient on A is just 1 over 1 minus B plus BT. In fact, this 1 over 1 minus B plus BT is just, in economic terminology, in macroeconomics, called what? What is this called? And it's just the multiplier. Yeah, just a multiplier. Okay. Now, what can we say about this term right here, about its sign? Can we figure out the sign of that expression? Yes, Andrew? It's going to be positive. How do you know it's going to be positive? Yeah. Yes, because B itself is less than 1. So 1 minus B is positive. This part right here we know is positive because B is less than 1. And B and T are both positive, so you're adding 2 positive things to the denominator. So this denominator, the overall denominator, has to be positive because those 2 terms are positive. So this is clearly positive. And what does that mean in words? See how easy this stuff is? What does that mean in words? Exactly. Y star and A move in the same direction. Okay. If A goes up, Y star goes up. If A goes down, Y star goes down.